Internet hardware. In this video, we're going to discuss the different types of hardware that make the internet run. To understand how the internet works, we must first understand that the internet is a global network. Now, what do I mean by that? Well, first off, a network is simply two or more computers that are linked together, two or more computers that are able to communicate back and forth with one another. Whenever you have a group of computers that are directly linked to each other and are able to communicate back and forth with one another, they form one network. And what the internet does is it takes a bunch of different networks across the entire globe and links them together so that computers across the globe will all be able to communicate with one another, thus making it a global network. So, how is a network constructed? Suppose I want my network to consist of only two computers. Well, in that case, all I would have to do is set up a single connection between those two computers. And through that one connection, I'll be able to communicate back and forth between those two computers. Now, suppose I want to add three computers to this network, and I want each computer in this network to be able to communicate directly with every other computer in the network. How could we make this possible? Well, one way would be to set up a connection between every single pair of computers in this network. Notice each computer has four connections coming out of it, connecting it to every other computer in the network. And for a small network like this approach would be fine. But this approach is not scalable. And what I mean by that is that this approach would not work for a large number of computers. There's not enough hardware to support every computer device maintaining a single connection to every other device in the network. So, what ends up happening instead is rather than give each computer a single connection to every other computer in the network, we give each computer one connection to a router that the computers will then use to communicate with one another. So, if for example, if computer A wants to send this flower to computer D, computer A will send that information to the router along with who the computer wants to send to, and then the router will forward that information to computer D. Now, this approach has its limitations as well, and that limitation is the fact that a single router can only handle so many computer devices. We can't assign a trillion computer devices to just one router. So, the way we solve that problem is by having second level routers that connect all the first level routers to one another. So that if a computer in one network wants to communicate with a computer in another network, the computer will send that information to the first level router, which will then forward that information to the second level router, which will then forward that information to the right network to get that info where it needs to go. And then likewise, when that second level router reaches its capacity, we create third level routers that handle forwarding information between all the second level routers. All in all, this is what contributes to making the internet a global network. A bunch of different networks all connected together and able to communicate with one another. The next question we'll explore in this video is how exactly does information get transferred from one computer to another? How does a 1 get transmitted? How does a 0 get transmitted? There are three types of hardware that's used to transmit ones and zeros from one computer to another: electricity, light, radio waves. First, we'll talk about electricity. An example of hardware that uses electricity to transmit data is Ethernet cables. An advantage of using electricity over the other options is that electricity is cheaper than the other options. However, they can only be used to cover medium to small distances. We can't use Ethernet cables or any other kind of electric hardware to transmit data across continents or overseas. So, that all being said, how does electricity communicate data? It does it through high voltage and low voltage. When a computer wants to transmit a 1, it'll run a high voltage through the electric wire. And when it wants to transmit a 0, it'll run a low voltage through the electric wire. Light. An example of hardware that uses light to transmit data are fiber optic cables. This is the hardware that's used to transmit data across continents and overseas. However, they're also very expensive, which is why they're only used to transmit data across very long distances. Now, that being said, how does light communicate data? It does so through intense light and no light. When we want to communicate a 1 using light, we use intense light to communicate that. And when we want to transmit a 0, we use no light to indicate that. Radio waves. Examples of hardware that use radio waves to transmit data include Wi-Fi routers, which you may have in your home, and cell towers, which is what cell phones use to transmit data from one location to the other. So, how do radio waves communicate data? Well, it does it through high frequency waves and low frequency waves. A high frequency wave signifies a 1, and low frequency waves signify a 0. So now that we have an idea of how a single bit of data gets transmitted from one location to the other, let's now discuss how a sequence of bits gets transmitted. Suppose I'm using electricity to transmit my bits, and I want to send the sequence 0101. Well, first I'm going to transmit a low voltage to signify the 0, followed by a high voltage to signify the 1, followed by low voltage again to signify the second 0, and then followed by high voltage to signify the last remaining 1. A simple enough concept for this kind of sequence. But now suppose my sequence contains 2 consecutive 1s in it. For example, 1101. Obviously, the first voltage is going to be high to indicate the first one. But how do I communicate the second one? How does the receiving computer know that I'm trying to send it 2 1s and not just a single 1? The answer to that question is a clock. What the receiving computer will do is every certain period of time, it'll check the status of the signal being sent to it. And whatever the status is at the point in time that it's checking, that'll be what the computer interprets. So, suppose our computer B, checks the status of its signal every 1 second. What the computer B will do is it'll wait a second, it'll see that the voltage is currently high, then we'll interpret that as a 1. It'll then wait another second, see that the voltage is still high, and thus we'll interpret that as another 1. It'll then wait another second, check the voltage, we see that it's now low, it'll interpret that as a 0. Wait a second, check it, we see the voltage is now high, and it'll then interpret that as a 1. Computer A will then shut off the connection, indicating that it's finished transmitting data. This approach is used not only for electrical connections, but for light and radio wave connections as well. We'll close this discussion by going over a couple very important vocabulary words. The first one being bandwidth, which is the speed at which bits are transmitted by a system, which is measured through bit rate, or bits per second. A computer with low bandwidth is a slow computer because it transmits a few number of bits per second. And a computer with high bandwidth is a fast computer because it transmits a large number of bits per second. The other important vocabulary word is latency, which is the time it takes a bit to get from the sender to receiver. Now let me reiterate, bandwidth measures the rate at which bits get transmitted, but that's a separate concept from how long it takes a bit once it's been transmitted to go from point A to point B. That's what latency measures. Latency measures the time it takes a bit to get from point A to point B. A connection with low latency is a fast connection because that means it takes a small amount of time for one bit to travel from point A to point B. A connection with high latency is a slow connection because that means it takes a large amount of time for a bit to travel from point A to point B.